Good day to you all. Welcome to the first lecture of radar plotting. Today we learn basic radar plotting. In the screen, we can see that there is a radar plotting sheet, and I will write down three range and bearing of a target in the radar plotting sheet. The first range and bearing I have taken at 0600 hours, and the range is 045 degree true, and the bearing is 045 degree true, and range is 10 nautical mile. The second range and bearing I have taken at 0606 hour. The range of the target at 0606 hour is 037 decimal 50 degree true, and range is 8.4 nautical mile. And third range and bearing I have taken at 0612 hours, and the bearing is 027 degree and 7.2 nautical mile range. Now I'll plot these three range and bearing in the radar plotting sheet. So you see, I have kept my pararoller at 045 degree true, and I have taken a divider, and I'm measuring now 10 nautical mile in the radar plotting sheet, and I have put my first range and bearing in the radar plotting sheet, and I have marked that one in the radar plotting sheet. So that is my first range and bearing. In that way, I will take other two range and bearing in the radar plotting sheet. Now I am taking second range and bearing. My second bearing is 037, and I am taking 8.4 nautical mile from the radar plotting sheet, and I have pointed that one. Then the third range and bearing, my third bearing is 027 degree true, and my range is 7.2 nautical mile. So I have got my three range and bearing. Now I am marking those range and bearing in the radar plotting sheet. Now what I do, I'll connect this three range and bearing, and I'll give it a name. The name is OA. What is OA? OA is the relative OA of another vessel. What does it mean? It means as I'm moving on a course 00 degree true at 15 nautical mile, and that time the ship is also moving, so the target will have a relative line of approach. So that three range and bearing is the relative line of approach of the target vessel. Right, now I'm writing down my own vessel properties in the radar plotting sheet. My own vessel course is 00 degree true, and my own vessel speed is 12 knots. Right, so these two things I have marked over there. Now what I'll do, I'll create a WO line now. Right, what is WO line? WO is the OA of own vessel. So how to calculate that WO line? Right, so for that I am doing a math in the screen. You see, in 60 minutes my vessel moves 12 knots. So in 1 minute my vessel will move 12 by 60 nautical mile, and in 12 minutes my vessel will move 12 into 12 by 60. So that means my vessel will move 2.4 nautical mile. So the WO will have the range of 2.4 nautical mile. As my vessel course is 00 degree true, I am taking 00 degree from the rudder plotting sheet, and I am putting, or I'm transferring that line on the O. You see, as I am transferring that line on the O, and in that line my WO line will be, right? Now what I'll do, I'll take 2.4 nautical mile from the range scale, and I will cut 2.4 nautical mile from O. That will give me my WO, right? You see in the screen, I am cutting 2.4 nautical mile, and I have got a point, and I am giving that point as WO. Right? Let us write down the meaning of two parts of the triangle. OA means relative OA of another vessel, and WO means OA of own vessel, right? Now what we'll do, we'll connect W and A. Once we connect W and A, the W and A will be OA of another vessel, right? I'm putting vector, and that vector is from W to A, right? You see, in that way we have got a triangle. The triangle is OAW triangle, right? Let us write down the meaning of WA as well. What is WA? WA is OA of another vessel, right? In that way, if we get three range and bearing, we can draw a OWA triangle. And once you have drawn the OWA triangle correctly, then actually we can solve other rudder plotting problems. We can get CPA, TCPA. We'll calculate that CPA, TCPA in the next class. Thank you.